we're going to talk about chemical and physical changes. In particular, we're going to talk about the relationship between the macroscopic characteristics and the bond interactions for chemical processes and physical processes. As you should recall, in chemical changes, bonds are formed or broken. Chemical changes can be represented by particle diagrams. This diagram shows how the atoms have rearranged themselves into new molecules. Bonds have been broken and then reformed. This diagram also obeys the law of conservation of mass, and if we counted them, we could see that we had the same number of atoms of each substance on each side. The breaking and formation of bonds is also represented in chemical equations. In this example, two substances, methane and oxygen, chemically react to form two new substances, carbon dioxide and water. The bonds in methane and oxygen have been broken, and new bonds have been formed. By contrast, in physical changes, no bonds are formed or broken. Physical changes can also be represented by particle diagrams. Here is an example of two substances being mixed. Notice that the molecules of the individual substances are the same before and after the change. We just end up with a mixture of the two different substances. In this example, we have a phase change. The figure on the left, which shows the before situation, shows a solid, and after the change, on the right-hand side, we can see that the solid has turned into a gas. So this would be an example of sublimation. In this example, we see that a mixture is being filtered, and that some of the residue particles are being collected on the filter. Physical changes can also be represented by chemical equations. Phase changes are a common example. One way we can represent the melting of ice is through this equation on top here. H2O solid goes to H2O liquid. We can also represent the vaporization of water with H2O liquid goes to H2O gas. And the bottom equation shows how we can represent the sublimation of dry ice or solid carbon dioxide. Now let's talk about a special situation, the dissolution of a salt. When a salt dissolves, ionic bonds are broken as part of the process as the ion-dipole interactions are formed. Hence, one could make an argument that dissolution of a salt is a chemical change rather than a physical change. And yet, a physical change is occurring. With the formation of the ion-dipole interactions, this is not a very straightforward situation, and in fact, you'll see that different textbooks talk about this differently, and there doesn't seem to be a clear consensus. For this course, you just need to be aware that the argument could be made in favor of either a chemical or a physical process or both. Now, let's summarize. Processes that involve the breaking or formation of chemical bonds are typically classified as chemical processes. Processes that involve only changes in intermolecular interactions, such as phase changes, are typically classified as physical processes. We can represent these processes through the use of chemical equations and particle diagrams.